In continuing our notes for section 3, we have some very specific kinds of lines that can occur in triangles. And knowing what they are, they give us different information. So if you have an altitude, that is a segment from one vertex perpendicular to the side opposite. Okay. The altitude, you may be familiar, it's what we look for when we're finding the area of a triangle. Here it's from A perpendicular to BC, and it happens to be inside of the triangle. Altitudes can also be dropped outside. Here's my triangle ABC, and my altitude here drops outside to get perpendicular, and you'll notice that because it has this dotted line. But that is where I get that altitude of my triangle. The last example is actually a right triangle which shows all three altitudes. Here is the first one, perpendicular. Here is the second one, perpendicular. And the third one drops to the middle, perpendicular. So if we know and we have an altitude, we know we have a 90-degree angle. Now, just to review from our last unit, we can have an angle bisector. And remember, this is a segment inside of a triangle which cuts the angles exactly in two. And if we know that, if we know we have an angle bisector, we know we get equal angles. Another segment that can occur is a perpendicular bisector. So perpendicular means 90 degrees, bisector, cut in half. Perpendicular bisectors can occur in a couple of different ways. This first example, the perpendicular bisector is cutting rather randomly through the picture, but we see that it is meeting at a right angle and cutting this base exactly in half. So here's our perpendicular and here is our bisecting. The perpendicular bisector we're going to talk about in section 4 is the one that's more interesting. And that is when it cuts down the middle of our triangle and it creates all sorts of additional properties. But for now, by the definition, we see that it bisects the side and it's at 90 degrees. If we take a second just to review some of the different special segments, here when we examine this picture, we know we have a segment that is perpendicular. This is an altitude because we do not know anything about the base. Here we have a perpendicular segment again, but we also see that it's bisected. And so this is one example of a perpendicular bisector. Here, this segment is telling us that we have equal pieces. And so what we know here is that D is the midpoint of AB. And so then that gives us that, CB, that CD is equal to DB. This segment, if we notice where our markings are, is at angle A, and this time we know we have an angle bisector, and what we know is that angle CAD is going to be equal to angle BAD. So all of these different segments could show up in a proof, and you get different information knowing what you're starting with, what you're being given. Go ahead and grab the next video in order to learn about mid-segments.